Hello everyone. In today's session, we are just going to learn about the theoretical distribution continuous case, in which we are just going to learn about exponential distribution and normal distribution according to your syllabus. These are the two continuous distribution involved in your probability queuing theory. So before letting into it, let us have the syllabus overview where we have theoretical distribution where we already discussed with binomial distribution and Poisson distribution previously. And now let us discuss about your exponential distribution and normal distribution where you don't have the uniform distribution and geometric distribution in each case. So now we'll just go and discuss about the exponential distribution. And let me define your exponential distribution. The exponential distribution is nothing but a continuous random variable defined in the interval 0 to infinity has a probability density function lambda e power minus lambda x, where x greater than 0. Very simple. This exponential distribution is very simple, and you have the PDF probability density functions lambda e power minus lambda x. And you can find this is applied in queuing theory and reliability theory, where the time to failure of a component or time between arrivals can be modeled using this exponential distribution. So let me first derive the moment generating function in the exponential distribution. So if it is a continuous distribution, we'll go with an integration minus infinity to infinity e power tx f of x dx. So we know what is your f of x PDF of this. It is lambda e power minus lambda x dx. So this is with integration x, right? So make the constant out. So lambda is constant. Next, let me go for e power. The power is common, right? The exponential is common. Make the grouping in the power. So it is e power minus lambda minus t, like making your simplification, like pulling your negative out. So it is e power minus lambda minus t of x dx, which is equal to lambda times of integration of e power minus x is e power minus x something. I'll just treat this as integration of e power minus x dx as e power minus x upon minus x minus the coefficient, right? Here minus 1. So here it is the same thing. Here the coefficient is minus lambda minus t. So it is written here. So apply the limit 0 to infinity. So 0 to infinity. When I'm just applying the upper limit, e power minus infinity is 0. Okay. So when I'm just applying the upper limit, it is 0. Minus of minus the lower limit. Because e power 0. So e power 0 will be 1, right? So it is lambda by lambda minus t. So that's what we got the answer for MGF is lambda by lambda minus t. So MGF of exponential distribution is lambda by lambda minus t. So using this, we'll just find similarly like mean and variance, how we did in a binomial and Poisson. So we'll go and find the first derivative of an exponential of a moment generating function, and letting t equal to 0 will give you the mean of your moment exponential distribution. So moment generating function of your exponential is lambda by lambda minus t. So this is we have to differentiate with respect to t. So we'll write this like d by dt of lambda by, because only t with respect we are just going to differentiate, right? So make it like conveniently this term. So differentiate this one. So it will get this lambda differentiation of, because lambda is a constant, right? We'll write it as it is. So it is minus 1 lambda minus t the whole power minus 2. Differentiation of t is minus 1. So now let t equal to 0. If I'm just letting t equal to 0, already we have lambda, and t equal to 0, we have minus, so it is minus 1. And here if I will make it t is equal to 0, I'll have lambda power minus 2. It is nothing but lambda, and here we have one more minus 1, that will become plus. So it is plus here. So it will become lambda by lambda square. So this will give you like 1 by lambda. Okay. So now mean of your exponential distribution is 1 by lambda. Similarly, let me go for finding your exponential of expectation of x square. We have to make the second derivative. So we already know what is the first derivative. Make it here and just go for the second derivation and let it t equal to 0. So we will get the answer as 2 by lambda square. So now find the variance, use the formula of the variance. So it is expectation of x square minus expectation of x the whole square, which is equal to 2 by lambda square, which we derived here. and the mean is 1 by lambda square. So finally we'll get the variance as 1 by lambda square. So the exponential distribution mean is 1 by lambda and variance is 1 by lambda square. So with this, we'll just move with the one more peculiar property in your exponential distribution, that is memoryless property of the exponential distribution. If x is an exponential distributed with a parameter lambda, then for any positive integer s in t, probability of x greater than s plus t such that s greater than s is equal to probability of x greater than t. So we'll just try to prove it taking a left hand side. So like this is, we have to use a formula of probability of A given B, the conditional probability, which is nothing but probability of A intersection. So we'll just use the formula of P of A given B, which is nothing but probability of A intersection B, conditional probability formula. So P of B. So here it is P of x greater than s plus t intersection x greater than s and this one. So this is like x is greater than intersection of x greater than s and greater than s plus t. Obviously it will be the one greater than s plus t, because if I have number like x greater than 5 intersection x greater than 3. So what will be the intersection? X greater than 3 starts from 4, 5, 6 and goes on. And x greater than 5 grows on only from 5. So the output will be obviously x greater than 5. So similarly, intersection of these two will be like x greater than s plus t. So now I know the PDF of your exponential distribution, right? So I have to find what is the value of the probability when x greater than s. So in probability of x greater than k, it is integral k to infinity f of x dx. So integral k to infinity f of x is lambda e power minus lambda x dx, right? So go for an integration with respect to e power minus lambda x here. So it is minus lambda. Apply the upper limit minus lower limit. When I'm just applying upper limit e power minus infinity, the first term vanishes because e power minus infinity is 0. So I'm just going for, so minus of minus will become the second one. And when I'm just applying the lower limit, it is lambda times of upper limit plus e power minus lambda k upon k. Sorry, lambda, because my lower limit na, so minus of minus will become plus. So this finally this and this get cancelled. I'll be left out with e power minus lambda k. So if it is x greater than k, it is e power minus lambda k. Using this logic, we'll write p of x greater than s plus t as e power minus lambda s plus t, because if it is greater than k, it is minus lambda k. If it is greater than s plus t, it is minus lambda s plus t. And if it is greater than s, it is minus lambda s. Now substitute in this formula. So it is e power minus lambda s plus t upon e power minus lambda s. So on simplification, we will finally get e power minus lambda t, and e power minus lambda t is nothing but probability of x greater than t. Got it? So next we'll just go with the problem like the time which is given in hours required to repair a machine is exponentially distributed with the parameter lambda is equal to 1 by 2. So what is the probability that the repair time exceeds 2 hours? So you have to find probability of x greater than 2. And what is the conditional probability that the repair takes at least 10 hours given that its distribution exceeds 9 hours? So at least 10 hours. So probability of x greater than or equal to 10 given that the distribution exceeds 9 hours. So x greater than 9. So we know the probability density function of your exponential distribution is lambda e power minus lambda x, and lambda in this question is 1 by 2. So it will be turning like this will become 1 by 2 e power minus x by 2. Okay, so for the first problem where it exceeds 2, so that means it integrals 2 to infinity 1 by f of x dx. So it will be like integral 2 to infinity 1 by t power minus x by 2 dx. So make an integration and apply the upper limit minus lower limit, you will get it. The answer is 0.3679. And come to the next one, probability of x greater than or equal to 10 such that x greater than 9. So we can go by direct formula, or else we can use the very immediate previous property called memoryless property. So memoryless property, what we know? Memoryless property. So what is that? Probability of x greater than s plus t given x greater than s is equal to probability of x greater than t. right? So it is like this is your S and this is your S plus T. So T is 1, so probability of x greater than 1. So x greater than 1, you can easily find it using the formula. It is 1 to infinity, integral 1 to infinity, f of x dx. So we'll get the answer. So it is not necessary to go with again the formula of conditional probability formula. We can use the memory list property if it is exponentially distributed. Okay. So coming to the next one, the mileage which car owners gets with a certain kind of radial tire is is a random variable having an exponential distribution with a mean of 40,000 kilometers. So mean it is given with a mean of 40,000. So mean of your exponential distribution is 1 by lambda. So your lambda is 1 by 40,000 kilometers. So the question is, what is the probability that one of these tires will last at least 20,000 kilometers? At least 20,000. So probability of x greater than or equal to 20. So your integration from 20,000 to infinity, and it is lambda e power minus lambda x. Here f of x is this thing. So we'll just go for an integration and we'll find the answer, right? And second one, at most 30,000 kilometers, at most, maximum. So it is x less than or equal to 30,000. So maximum in the sense it is the upper limit 30,000 and lower limit because my PDF is valid from x greater than 0. So it is dx. It's 1 minus e power minus 3 by 2, 3 by 4. So we'll get the answer is this one. So similarly, the next problem will be the same scenario like the length of a person speaks over a phone follows an exponential distribution with a mean of 6. So 1 by lambda is 6. So from this I can find lambda is 1 by 6. So corresponding PDF is this thing. So this will turn as 1 by 6 e power minus x by 6 for x greater than 0. So according to this problem, this is your f of x. Right? So what is the probability that the person will talk for more than 8 minutes? So more than 8 minutes is greater than 8 and less than 4 minutes is less than here and between 4 to 8. So it is more than 8 minutes is p of x greater than 8. So it is 8 to infinity f of x dx. So we'll just integrate it and substitute the upper limit minus lower limit and you'll find the answer. And if it is less than 4, it is the upper limit will be 4 and lower limit will be 0 for the integral. And we'll proceed for the integral of the PDF given. Integral 0 to 4 f of x dx and integration upper limit minus lower limit will be finding answer correspondingly. And if it is between 4 to 8, so the limit of the integration is 4 to 8 f of x dx. Perform the integration and apply the upper limit minus lower limit. You will find the answer. And coming to the next one, the next problem, the amount of time that a watch can run without having to be reset in a random variable is a random variable having an exponential distribution with the mean 120 days. So again, it is given mean, not given lambda directly. They have been specifying it is mean is 1 by lambda. It's 120 days. So your lambda will be 1 by 120. Find the probability that such that a watch will have to be reset in less than 24 hours, 24 days. So f of x according to this lambda, you will rewrite it. So less than 24 days. So its probability of x less than 24. So integral 0 to 24, 1 by 120 e power. We'll substitute the f of x. Integral 0 to 24 and f of x dx. We'll perform the integration. Apply the lower limit and upper limit. Upper limit minus lower limit. You will get the answer. So coming to the next one, finally the number of kilometers that a car can run before its battery has to be replaced is exponentially distributed with the average of average in the sense mean is given, right? So with an average of 10,000 kilometers. If the owner desires to take a tour consisting of 8,000 kilometers, what is the probability that he will be able to complete his tour without replacing the battery? So according to the problem, your mean is 1 by lambda. So your lambda is 1 by 10,000. So accordingly, we will rewrite your distribution, right? So PDF of the distribution, it is 1 by 10,000 e power minus lambda by 10,000 for x greater than 0. So here, what's the question? If the owner decide to take a tour consisting of 8,000 kilometers, what is the probability that he will be able to complete the tour without replacing the property? That means if it is greater than 8,000 only, he will not be able, he will not be replacing the battery, right? So So probability of x greater than 8000. So it is 8000 to infinity, 1 by 10,000. That we will substitute f of x dx. So go for an integration. Apply the upper limit minus lower limit. So always if it is infinity, e power minus infinity is 0. So only the lower limit value exists and we'll find the answer. Right? So coming to the next problem, in a construction site, 3 lorries unloaded material per hour. On an average, what is the probability that the time between arrival of the successive lorries will be at least 30 minutes and less than 10 minutes? So according to the given question, the mean is 3 per hour, right? So lambda is equal to 3. So the first one, what is the probability that the time between arrival of the successive lorries? So here lorries unloaded per hour. So here at least 30 minutes. So we have to convert the question. Either this one is minutes or this one is hours. So here we have converted into hours. So 30 minutes is half an hour. So here at least 30 half an hour. So x greater than or equal to 1 by 2. So integral 1 by 2 to infinity. And correspondingly here f of x. So f of x is lambda e power minus lambda x for x greater than 0. So if it is upper limit, just go for an integration. Apply the upper limit minus lower limit. Whenever it is upper limit is infinity. So e power minus infinity is 0 here and lower limit values exist. So we'll get the answer. Similarly, for the next question, it's equal to 10 minutes. So convert into hours. So it will become 1 by 6. So it will be like less than 10 minutes. So it's x less than 1 by 6 hours. Converting, right? So less than, so this is 1 by 6 will be the upper limit and lower limit will be 0. So f of x dx. So we'll be performing the integration, applying the upper limit minus lower limit, we'll be finding the answer. So this is a procedure to go for the problems in an exponential distribution where you'll be given a question like the parameter lambda, not directly, they'll be giving like specifying this is your mean. So from, you should know mean is 1 by lambda. From that you have to coin what is your lambda and accordingly you have to write your exponential PDF based on the lambda. Then you find it what is asked in the question, whether it is greater than or at least or at most. Accordingly, the upper bound and lower bound of the upper limit and lower limit of the integration varies. Okay. So with this, we'll end with the exponential distribution. Thank you.